Hello everyone and welcome to our channel. In our previous video, we showed you how to use the MariaDB connector to connect to Power BI desktop and use our MariaDB server and databases for practice and learning. Today we will discuss the core concepts of data modeling in Power BI and we will use this database to create a star schema. We'll use the MariaDB server database for today's exercise, but you can perform same data modeling techniques using any type of data source. And for that purpose, we have also provided this database in Excel and CSV format, and you can download those files from here, and you can perform the data modeling, and you can create star schema on this database using those files as well. All you have to do is click on this link and you can download these files and use them in your Power BI desktop application. So let's go to the Power BI desktop application and click on the get data, and from here we will search for MariaDB. We have already installed the MariaDB connector, so let's click on the connect button, and now we need to enter the server name, which is this IP address, and then we will add the database name, and now we will click on the OK button. In the navigator window, we have all the tables from this database, and we need all of these tables in our Power BI desktop application. So let's select all of these tables. And now we can either click on the load button, which will load these tables into the data pane here, or we can click on the transform data, which will take us to the Power Query window. Now the Power Query window or M language is used to transform the data, and the data modeling is often done in the Power BI desktop application itself in the model view. But you can also perform data modeling in the Power Query window as well. So let's click on the transform data and let's show you what kind of data modeling you can perform in the Power Query. So let's click on the transform data. And now we are in the Power Query editor, and these are all the tables that are in this database. And this is the sales table, which is a fact table, and these are all the dimension tables. And in the sales table, we have the product ID here and the number of units sold, but we do not have the actual sales value. And in the product table, we have the product ID and we have the price per unit of each product. So in the sales table, we do not have the actual sales value, and we can calculate the sales value by multiplying the number of units with the price. But we have price in the product table and we have number of units in the sales table. So we need to combine these tables, the sales table and the product table, to come up with the actual sales value, and we can only do that through the data modeling. And in the Power Query editor, we can perform data modeling using the new query. And to do that, we need to click here, and we can either use the blank query and then write the M language code by ourselves and create a join between those tables, or we can use the combine menu and click on the merge query as new. And this will take us to the merge window where we can select both tables. So let's select the sales table first and then select the product table. And in the sales table, we will click on the product ID column, and in the product table, we will click on the product ID column as well. So these will be connected. These columns will be our relationship between these two tables. Let's select the left outer join and click on the OK button. And now we have a new table where we have a product column, which is actually the entire product table. So we can click here and we can select the desired column from these columns. So let's select the price column because that is what we want here. We can select all of them, and these all will become the part of sales table. But for right now, we will only select the price column. So let's click on this one and click on the OK button. And now we have the price of each product in the sales table as well. And now we can calculate the sales value. And to calculate the sales value, we'll go to the add column and click on the custom column. And here we will enter sales and we will click on the units to add the units into the query and multiply units with the price. And then we will click on the OK button. And now we have sales in our sales table. As you can see, sales is the multiplication of price into number of units. And this is how we perform data modeling using M language in the Power Query editor. However, the actual proper data modeling is performed in the Power BI desktop application using the model view. So this was just to show you how to perform data modeling in the Power Query editor. So let's click on the close and apply button and load all these tables into the Power BI desktop application and perform data modeling there. So this will load all our tables in the data pane from where we can use these tables and their fields in our Power BI reports. So now we have all the tables in Power BI desktop application. Now most of the modern applications such as Power BI desktop perform relationships between tables on their own. They can assess the related columns and they connect those columns with other tables automatically. That all depends upon how cleverly these tables were designed. So, for example, we have the sales table where we have channel ID, customer ID, etc., all IDs. So, let's see. Let's open the channels table, and as you can see, we have a channel ID here. So these applications can assess that this channel ID must be connected to this channel ID. Similarly, this customer ID will be connected to this customer ID. So till now, we did not connect these tables uh, by ourselves. So let's go to the model view and see if any of these are already connected or not. So let's click on the model view and here you go. As you can see, all of the data modeling or most of the data modeling has been performed automatically on its own before even we open the model view. Only few tables are left for us to connect to other tables. So let's see if we can create these relationships manually. So the bank table was supposed to be connected to the stores table, which we either forgot to import or which was not imported due to some reason. So let's go to the Power Query editor. In the Power Query editor, we need to import the missing tables. In the same way, we have all these tables. So the easiest way to do that is by using an existing table. So let's create a duplicate of this table and call it delivery status. This is one of the missing tables. So let's go to the source tab and here we have all the tables listed and delivery status is although not one of those, but since this table exists in the database, it does not matter if it is listed here or not. So if we go to the navigation step and in the name parameter, if we paste the name of the table and click on the OK button, this will bring us the delivery status table and here it is. So in the same way, we can make a duplicate of this table and call it store location. This is the other table that we failed to import uh, previously. So again, let's change this delivery status to store location and click on the OK button. So this table has been imported as well. So now we have all the tables. So let's click on the close and apply button, and this will update the list of tables in the data pane as well. So here we have the store location table, and here we have the delivery status table. Now we can go to the model view, and as you can see, now we have the relationships, the updated relationships as well. So the previously tables not connected to the other tables are now mostly connected. And now that we don't have any missing tables, let's connect the other tables to the tables that they need to be connected to. So let's connect the brand table to the product table using the brand ID. And here it is, brand ID, and one to many. So this table will have one, and this table will have many brand IDs. So this is a one to many relationship. Uh, let's click on the save button, and now this table is connected as well. The marital status table must be connected with the customer table, and here we have the customer table, and this is the marital status ID. So let's select the connect the marital status ID to the marital status ID here, and let's click on the save button, and now this is connected as well. So now we have all the relationships, and this is our data modeling where we connect all the tables to each other. And here we have an extra table that was used to demonstrate the data modeling in Power Query. So we do not need this table. It will make the data modeling less complicated here. So let's delete this from model. Click on the yes button. And now we have less relationships, and we did not need that table. So it is gone now. And things are a little bit simple now. We also need to connect the product and sales table using the product ID field. So let's use this to connect to the sales table using the product ID and click on the save button. And now that our data modeling is complete, let's go to the table view. And as you can see, in the sales table, we do not have the sales value. We have the number of units, and we have the price in the product table. So we can calculate the sales value in the sales table by multiplying the number of units with the price column, but we have the price column in the product table. In the Power Query editor, we combine the sales table and the product table, and to bring in the price column from the product table into the sales table. And in the Power Query, we used a new table to do that. But here, since we already have our data model and we have relationships between sales and the product table, we can simply create a new column. And let's call this column price. And we can use the related function here to bring in the price column from the product table. So let's click on the enter button, and here we have the prices from the product table into the sales table. So as you can see, the price is same for the product ID 1, and as soon as the product ID changes, the price will also change. So now we can create another column and call it sales, and in this column we can multiply units to the price column. And now we have the sales column, which is the multiplication of price and number of units. So this was the use of DAX related function, which can only be used if there is a data model and there are relationships among various tables. In addition to this function, there is also a related table function. So let's use that as well. So let's create a new column here and let's call it sales. And let's use the sum x function, and in the table parameter, let's use the related table and let's select the sales table. And in the expression, let's select sales. Let's see what happens. And now we have sales in the product table as well. So we have the sales value of each product in front of that particular product, and we use the related table function in the product table. So there are many DAX functions that can only be used if there are relationships in our data model. And as you can see, there are many fields that we don't use in our visualizations, but they exist in our data model. And if we go to the report view, you can see that these are a lot of fields, and these are ID fields, which we don't use in our visualization. So if you want to hide these fields, you can simply go to the data model and click on this icon, and they will disappear from your data pane. This will give you a clean look of your data model, and the fields that you only use for your visualization will appear here. In addition to everything that we have discussed so far related to data modeling, you can also create a dedicated date table. Although you have dates in your sales table, which you can use for the purpose of time intelligence analysis, but it is recommended that you have a separate uh, date table in your data model. To create a separate date table, we can go to the table view, and in the table tools, we can create a new table, and we can call it date table. We are still going to base our date table on the dates in the sales table. So let's create a table using the calendar function, and let's take the minimum date from our sales table, and then let's take the maximum date from the sales table as well, and this is it. So now we have dates based on our sales table, and now we can create some other columns in this table that we may use in our future visualization. So let's create a new column and call it year, and let's use the year function based on uh, date column, and now we have year from the date column. In the same way, we can create a column for month, and we can get month from the date column as well. And again, let's extract day from the date column as well. And we may want to also add the name of the month to our table. So month name is equal to format. We will format the date field as mm, and this will give us the name of month instead of month number. And finally, we may also want day of week. So again, let's use the format function and use the date field, and let's format our date field as day of the week. So now we have the day name as well. And instead of day of the week, we can also call it day name, whatever suits you. So now we have another table to our data model. So let's go to the model view and let's see. The relationship has not been created. So let's create a relationship between the sales table and the date table based on dates. So here is the date column in the sales table, and we have the same date field in the date table as well. So let's connect both, and we are using many to one relationships. So after creating the relationship, just click on the save button, and now our date table and the sales table is connected, and we can use the date table to perform time intelligence analysis on our entire data model. Another thing that you can do in your data modeling is create hierarchies. So if we go to the table view and in the date table that we just created, you can see that dates are automatically converted into hierarchies. We may have other hierarchies in our data model. For example, if we go to the store location table, we can see that region, country, and city can be converted into a hierarchy, but it is not automatically recognized by the Power BI. So we can manually create or convert it into a hierarchy. We simply have to right click on the field and click on the create hierarchy. So now that field has gone into a region hierarchy. So we can also bring in the country by right clicking on the country field and adding the field to the region hierarchy. And then we can also add the city in the same way by adding it to the region hierarchy. So now we have a region hierarchy, and you can use this hierarchy in your visualization. So for example, we can simply bring in this entire region hierarchy here, and it will look like this. And it has automatically included region, country, and city, and it is better used in the slicer. So it will look like this in the slicer. So this is how you can organize your hierarchical data in Power BI using hierarchies. The core component of data modeling is the relationships, and there are many types of relationships, and we have only used one-to-many relationships. One-to-many relationships are used in schemas such as star schema, and here uh, one table contains individual IDs, and they are repeated in the other tables, and when they are connected, they use one-to-many relationships. And in these type of well thought of or well organized tables, there is no need to use one-to-one or many-to-one or many-to-many relationships, but they exist. So today we will also demonstrate those types of relationships, but for those we will use another data set. So let's open another Power BI file, and let's create a blank report, and let's open an Excel file and load all tables in the data pane. And now we have all tables in our data pane. So let's go to the model view. And as you can see, since this data set is not well organized, the relationships are not automatically detected. So we have to create these relationships manually. So let's start with these two tables, and let's go to the table view. And as you can see, the cost table has dates and costs. And you can see that dates are not repeating. And in the sales table, we have the date column and the sales column. And again, dates are not repeating. So let's go to the model view and connect these tables using the date fields. So as you can see that it has automatically created a one-to-one relationship because in both tables, dates are not repeating. And since it is a one-to-one relationship, it can also accept the cross filter in both directions. So that has automatically been chosen as well. And we can also deactivate this relationship, but we want to keep it as an active relationship. So let's save this relationship. And now our cost and sales tables are connected. Next, we have a sales team table. And sales team table also has a date column. So let's see. Let's go to the sales table, and as you can see, it has the date column and it has dates, but these dates are repeating. So uh, it is January 1st, 2025, and Jack has made this many sales. But on the same day, John has also made this many sales. So the dates are repeating. We can see more clearly if we sort these dates. And now we can see that each date is repeating two times. So if we connect this table to the sales table using the date fields, the relationship will be one to many. One to many means that sales table has unique dates and the sales team table has repetitive dates. Therefore, the relationship is one to many. And since one to many relationships are ideal for single direction for cross filtering, the single is automatically selected. So let's save this relationship. And now our sales team table is connected to the sales table. And now we have one to one relationship and one to many relationship. And now we have a customer table. And if we go to the table view, in the customer table, we have salesperson and customer and then sales. And the problem is that salesperson is also repeating and the customer is also repeating. So if we go to the model view and connect the customer table to the sales team table using the salesperson field, it will be a many to many relationship because the salesperson, the key that we are using to connect these two tables is repeating in both tables. And this type of relationship is not at all recommended. So you must avoid these type of relationships at all costs. But here, just for demonstration, we are creating this relationship. And let's click on the save button. And now you can see these two tables are connected and they are connected using the many to many relationships. And now we need another table and let's use enter data to create a table. And this table is receivable table. So let's call it receivables and let's load this table into the data pane. And now let's go back to the model view. So now we have another table and interestingly, the relationship has automatically been created by Power BI. So let's see what relationship it has created. So it has created a many to one relationship, and that is the specific relationship for which we created this table. And we created this table to demonstrate many to one relationship, and Power BI automatically detected this relationship and created it for us. So let's save this relationship, and now we have all types of relationships. This is one-to-one relationship, this is one-to-many relationship, and this is many-to-many relationship, and finally we have many-to-one relationship. Now, using these relationships and data model, let's create a visualization. So let's add a title, and then let's add a date field here, and fields like this. And then let's add costs. Since cost is related to the sales table, we can bring in cost from cost table into this visual. So now we have cost as well. Now let's create a donut chart and add the customer to legend and sales to values. Then let's add another donut chart and let's add customer to the legend and receivables to the values as sum. And another one. And let's add salesperson here and sales here. So now we have a dashboard, and as you can see, the relationships are working fine. So this is how we create data models using the one-to-one, one-to-many, many-to-many, and many-to-one relationships in Power BI. So today we used two data sets. One is in Excel file, and the other one was SQL Server, MariaDB server. And the link to the server database is available on our website, which has already been shown. And the dataset in the Excel file will be shared using Google Drive in the comment section. And with this, we end our today's tutorial on data modeling. And we'll see you in another video. Till then, have a nice day.